X minus h squared
plus y
y
minus
k
k squared equals the radius squared. That's what you gotta do.
Okay, and the center will be the h and the k, and the r is obviously the radius. So could we, because we know those two things, write the equation for this circle?
Yes.
What would it be?
It would be x minus 3 squared.
Good, because it went 3 to the right, so we did minus 3.
Yeah. Y plus 2
Plus y plus 2,
squared.
because instead of going 2 up, we went 2 what? 2 down. Change inside, right? Anytime change is inside, you're going in the opposite direction. Equals what?
25.
25, which is r squared. A popular question on the SAT regarding this is they give you the equation of a circle, and then they ask you for like the area of the circle. So you need to be able to recall that r comes from here, right? So you can find the area.
What's the formula again for area?
Pi r squared. We'll review that next week.
Wait a minute.
Okay? Good? So let's find the derivative of this equation, which represents this circle, okay, implicitly. Can we do it?
Yeah.
Let's go. Alright, what's the derivative of this part gonna be?
1.
2 times
Two
x minus 3.
X minus 3, okay?
Yes.
Technically times
Times
dx dx, which is
1.
1. Okay. So eventually you won't have to show me that anymore. Plus what?
2
Parentheses y plus 2 times
times
dy dx equals 0, the derivative of 25. So we know this becomes a 1, so we have 2 parentheses x minus 3 plus 2 parentheses y plus 2 dy dx equals 0. Can I make this just dy dx equals, which is what I ultimately want to do? Let's do it. What would I have to move?
2x minus 3.
Move this guy?
Yeah.
Okay, so I'm gonna have 2 parentheses y plus 2 times dy dx is equal to negative 2 parentheses x minus 3. Are we okay?
Yeah.
And then we would have to divide by,
2 parentheses y plus 2.
okay, divide by 2 parentheses y plus 2. So we finally end up with the derivative with respect to x being
Do I do x?
negative parentheses x minus 3 over y. So this is a formula that will give me the slope of all the tangent lines that I could draw at any point on the what?
Sir? On the curve?
On the circle, right?
Oh my god.
Sorry, I got distracted.
I was like,
Good? That's gonna be weird on the video. But anyway.
And
and now Sony Vegas surprise.
Alright, so let's look at one of the points. Let's look at the point 3, 3. Okay? So if I go to 3, 3, what kind of a tangent line should I have there? Horizontal, right? So that means that the slope should be 0. That means that the derivative should be 0, right? So if I come down here and I want to evaluate the derivative at 3, 3, I'm going to plug in 3 for x and 3 for y in this derivative equation. And my answer should end up being what? 0. So let's see. Negative parentheses 3 minus 3 over 3 plus 2. What do I get here? 0 over 5, which technically just means what? 0, therefore giving me what kind of a tan line? Horizontal tan. Cool? If we're going to have a vertical tan line, can you give me a point where that would happen?
Negative 2 and
8, negative 2.
8, negative 2? Alright, so right here, I should have a vertical tan line. And what would the slope of that tan line be? Undefined, right? So let's see what that would look like. What would that look like as a fraction?
A number over.
A number over 0. Okay? So 8 negative 2, what do you know? What a coinkadink. So here we got dy dx equals, and let's plug it into the derivative formula. So negative parentheses 8 minus 3 divided by negative 2 plus 2. Do we end up with a number over 0?
Yeah.
Here we get negative 5 over 0, and that ultimately means what?
Undefined.
Undefined, and that will create what on our circle?
Vertical
A vertical tangent. It's gonna be important for you to know when I have a horizontal tan line, when I have a vertical tan line, because you're gonna notice that on AP questions, they're gonna ask that. They're gonna give you a function written implicitly, and they're gonna say, find where this implicit equation has a horizontal tan line. Okay? So you're gonna know that you have to find its derivative and then equal what part of its derivative to 0.
The up or down.
For horizontal. The top, right?
Numerator.
Okay? So find where it has vertical tan lines, that would equal the denominator is 0. Does that make sense? Okay? And that's either gonna give you an x value or a y value, because it is implicit. Okay? Sometimes they'll ask for the whole point. So if I know x or I know y, how can I find the other one? Plugging them into which equation?
Original.
The original. Does that make sense?
Yes.
Pretty good? Alright, let's do one more, okay? Let's do this first one at 0, 2. Okay? So here we want the derivative with respect to x at 0, 2. This is going to be negative parentheses 0 minus 3 over 2 plus 2. We get 3 over what? 4. So that should be a tan line that has a what?
Slope.
Positive slope, right? 3/4? Okay, so let's go to that point, Antonio, 0, 2. And let's draw a tan line that has that slope. So we're gonna go 3 up, 1, 2, 3, and 4 to the side. 1, 2, 3, 4. We're gonna go 3 down and 4 to the left. So that way we have at least 3 points to try to make that tan line as best as we can. Beautiful? And if I drew an infinite number of tan lines, what would those tan lines create?
A circle.
The circle, right? Ooh, how pretty, right? You wanna draw more and more?
No.
Sure?
No.
You believe me that it'll make that
I
circle?
believe you 100.
Do you believe?
Yes.
Good.
What's the problem?
Is that enough examples of doing this? Or do you
Yeah.
wanna go through
No,
more?
we're fine.
You're okay?
Yeah, we're
Pretty simple, how to evaluate the derivative? Is it the same thing as the other one?
Yeah.
Yeah, except now you have 2 different letters to replace, right? So you know, not only need an x number, but a y number. Alright, so now to the actual major thing that we're doing in this lesson is more practice on finding derivatives implicitly, and I kind of broke it down into steps here. You've already done these things, you just didn't know you were doing them. Alright, so all the time when they're asking you to find the derivative, implicitly, the first thing to do is get the derivatives of both sides of the equation. Here, because we're doing it with respect to x, that's what we're gonna get the derivative of. So you gotta check, do the variables match? X, x, y, y, x, y, oh no. Okay? Yes? Alright, second thing is, move all the terms that do end up with a dy dx in them to the left. Okay, they don't always have to be on the left. If it's easier to just leave them on the right side because they're already there, then leave them there. But what I'm getting at is that they have to be what?
Equal to dy over dx.
They have to be
Alone.
together, right? Okay, because I might have this guy with dy dx and this guy with dy dx, but I want them to both be on the same side. Make sense? Alright, so once I have 2 things that have dy dx on the same side, well, don't those 2 things have something in common? Yes? They're gonna have that dy dx in common, so that's why it's telling you to factor it out. Okay, we didn't have to do that on any of the problems we had right now, but we will. Good? And the last thing is to make it dy dx equals. You think we can get through that? Let's give it a go, okay? We have 1, 2, 3, 4, 5, 6 examples, and I think we can do them all. You ready? Woo! Let's do it. Alright, so find dy dx for each of the following implicitly defined equations. So this is our ultimate goal. Make it dy dx equals everything else. You ready? Let's go. go. Step one, get the derivative of both sides. So get the derivative of this guy. 2y. Uh-oh, letters don't match. So times what? dy dx equals, okay, derivative of 2x. Two letters match, so I don't have to worry. Plus derivative of 3y. Uh-oh. 3. The letters don't match, so we have to put dy dx. Awesome. Step one's done. Step two says to move what? Move the terms that have dy dx in them all to the same side. In this case, to the left. So that means we gotta minus this guy, so he can be over here. So I have 2y dy dx minus 3 dy dx equals what? 2. Are you with me or you're lost? Because I didn't show the minus on the other step. You okay? Alright. Okay, these problems take up a lot of space, especially if you show every little step, so I'm assuming that you can follow me by now. Okay? So what would I do next? What does it say?
Factor out.
Factor out what they have in common, which should be a dy dx. 2y minus 3 should be left over. And the final step is to make it dy dx equals. What would I do? Divide by all that stuff that I don't want. So 2 divided by 2y minus 2. And we're done. Did we find the derivative? Yes, with respect to x. Cool?
Mr. Fence, can you cancel out the 2?
Can I cancel out the 2's?
No.
No, okay? Is there common terms, not common
Fact.
factors? If I was able to take out a 2 from both of these guys and make it 2 times everything else, then yes, I could cancel out the 2's. But I can't do that. Okay, be careful. Another one?
Yes.
Another one. Alright, here we go. So let's go. Derivative of the left, so 2x. Derivative of 2x. 2. Letters match, we're good. Plus, derivative of e to the y.
E to the y times y
E to the
prime.
y
Times y prime.
times y prime, which we're not going to write it like that, but we're going to write what? dy dx. Yes? Doesn't that represent the derivative of y?
Yeah.
Okay, can we keep going? Equals the derivative of x squared?
2x.
2x, no problem, it matches. Minus the derivative of y squared. 2y dy. Alright, cool. So now in your mind, move stuff around and tell me what will be on the left side.
dy dx
E to the y dy dx
plus 2y
plus 2y
equals 2
dy dx. Why plus, Adrian?
Because you are.
Very good, because you're moving it from one side to the other, right? So when you want to cross the bridge, you got to pay the fee, right? Equals
2x minus 2x.
2x minus 2. So you left that guy there, but you moved this one over, so you have to subtract. Is everybody okay? Alright, so now what do these two have in common?
You are doing.
dy dx, and we're left with e to the y plus 2y equals 2x minus 2. And finally, we can finish this guy by dividing. So we get 2x minus 2 over e to the y plus 2y. That's what I would use to do different things with. Find different slopes of different tangent lines, find equations of tangent lines, find equations of normal lines, find where I have horizontal tan lines, find where I have vertical tan lines, all the beautiful things that I usually do with derivatives. But now we're doing it with the implicit derivative. Cool? Maybe? Not really?
No.
Let's keep going. We're going too slow. Okay, crank it up. That's our AP. Apenas puedes. Alright, 2xy equals 3y squared plus 2x. Okay? So, we got 2xy. So to get the derivative of that, we would have to follow what rule? Product rule. Are we ready?
Yes.
Alright, so product rule says derivative of the first, I'm going to put the 2 and the x together, since 2 is just a constant, and treat that as being the first. So what's the derivative of 2x?
2.
Times the second? Y. Plus the first? 2x times the derivative of the second?
You like it.
dy dx, beautiful. Equals derivative of 3y squared, 6y times dy dx, beautiful, plus. Alright, that's easy, man. Just get the current stuff. Okay, so in your mind, move things around and factor out the dy dx at the same time. Can you do that?
Yes.
You sure?
Yeah.
I'm on it. I'm on it. Okay, so you factor out the dy dx. What's left
Oh,
over?
you skipped two
I
steps.
skipped 2 steps. You said?
Okay,
You said you could do it?
2x minus 6y.
2x minus 6y?
Yeah.
Oh, it alone? What? Equals what?
2y.
Negative.
No, 2y. 2 minus 2y.
2 minus 2y?
Yeah.
Oh my god.
Yes? Oh, you're good. Skip 2 steps.
Yeah.
Alright, and then we got dy dx equals? You think you could skip all those steps and jump straight to this one?
Yes, I triple dog there.
Triple dog dare me on the next one? Do I need to go back and put the other steps, guys?
No.
Are you sure?
No.
Yes, somebody said yes. So 2x dy dx minus 6y
Hello, I didn't say anything.
dy
All the steps are there.
equals